All right, guys, for the last part of this chapter, we're going to talk about radioactivity. So get your notebooks out and copy all these notes into your notebook. So radioactivity was discovered in the late 1800s. They discovered that some elements change into other elements spontaneously. And this was an accidental discovery in 1896 by a scientist named Henry Becquerel, who studied minerals containing uranium. And he saw that uranium had a reaction with photo paper, even though there was no light or anything to affect it. So the next scientist who really made strides in radioactivity were Paris and Marie Curie. They were husband and wife, and they discovered that elements that emit radiation, that radiation is made of energy and particles, and the particles come from the nucleus, and you get a change in proton number. And there are three ways we can show that this is happening. So this happens through a process called nuclear decay, when an unstable atomic nucleus changes into a more stable nucleus by emitting radiation. There are three types: alpha, beta, and gamma. So during alpha decay, your proton or your atom loses an alpha particle. That means they lose 2 protons and 2 neutrons out of their nucleus. And when released, the atomic number will decrease by 2. The next type is beta decay, and this is when an atom's nucleus loses a proton and a high energy electron called a beta particle. And what happens here is your atomic nucleus number increases, so it gains a proton. Gamma decay is when there are no particles lost, but your atomic nucleus loses a large amount of energy. This one doesn't change into another element, but it is also the strongest one and can pass through lead. So radiation can be harmful and beneficial. It can damage our cells, and it can destroy cancer cells. So a lot of you have heard about radiation or somebody who is having radiation treatment, and that's when they use these radioactive particles to target cancer cells and destroy them. So alpha, if you look at the picture, is the weakest of our radiation. It's stopped by paper. Beta is a little stronger, and that can go through paper, but is usually stopped by plastic and any solid substance. Gamma is the strongest. That can go through paper, lead, steel, and it's very, very dangerous, as you'll see in the video that you watch on Marie Curie. So what you're going to do is I have a TED video you're going to watch. You are going to then complete the think questions and answer the discussion question. We are probably this is probably going to take 2 days in class. So I'm going to assign this for Monday and Tuesday. So today we'll talk about the different types of radioactivity, and then tomorrow we'll talk about our video. So that's all, and I'll see you this afternoon.